Welcome back, everyone. Ready for another deep dive? Today, we're stepping into the fascinating world of predictive maintenance, specifically how AI is changing the game.
Yeah, it's a pretty hot topic.
It really is. Now, think about this. You're in a factory, everything's humming along, and suddenly, bam, a vital piece of equipment just decides to call it quits.
Hmm.
Production grinds to a halt, costs skyrocket, and, well, nobody's happy.
That's the nightmare scenario.
Exactly. And that's where predictive maintenance comes in anticipating problems before they turn into those major headaches.
Right, getting ahead of the curve.
And this research paper from the Journal of Machine and Computing, well, it's suggesting a pretty radical approach predicting machine failures just by looking at their speed.
Hmm, speed, huh? That's interesting.
I know, right? It might not seem like the most obvious factor, but it turns out speed can tell us a lot about a machine's health.
So, like, how's that even possible?
Well, think of it like your car. If the engine suddenly starts revving higher than usual, even without any warning lights, you'd probably get a bit suspicious, wouldn't you?
Yeah, like something's off.
Exactly. And this AI model, it's called a Convolutional LSTM neural network autoencoder.
Whoa, that's a mouthful.
I know, right? But don't worry, we'll break it down.
Mhm.
Basically, this AI can pick up on those subtle changes in speed patterns like your car engine, but way before a human would notice anything.
Okay, so it's like a super sensitive speed detector. But how do we know it actually works? Did they, like, test it out?
Oh, they definitely put it to the test. They used a real-world data set from a vertical form fill seal machine think food packaging and compared it to three other standard models, kind of like a speed dating competition for AI, each one trying to be the best at predicting failures.
Uh-huh. I like that analogy. So who were the contestants?
All right, so we've got RSNet, CNN, LSTM encoder decoder, and LSTM encoder decoder.
Okay, got it. And how they judge this AI speed dating contest?
Well, they use three main metrics, RMSE, MAE, and sMAPE. These are just ways to measure how accurate the AI is at predicting those potential failures. The lower the score, the better.
Okay, lower's better, got it. So how did our speed-savvy AI do?
It crushed the competition. They started by analyzing the data using a window size of 45, meaning the AI was using 45 data points to make its predictions. And with that, our AI scored an RMSE of 58.45. The next best, the CNN LSTM encoder decoder, had an RMSE of 76.93, and the other two, well, let's just say they weren't even close.
Wow, so almost a 20-point difference. That's impressive. What about the other metrics, MAE and sMAPE? Did it keep winning?
Oh, absolutely. For MAE, it scored 22.48, again, way lower than the others. And sMAPE, another win with a score of 0.869, showing even more accuracy.
Okay, this AI is clearly a top contender. So what do these scores mean in the real world, though? Like for a factory manager, what's the takeaway?
Imagine knowing about a potential machine failure days or even weeks in advance. You could schedule maintenance during downtime, minimize disruptions, and save a ton of money.
Right, no more last-minute scrambling or emergency repairs. That's huge.
It's a game changer. But I'm curious, is a window size of 45 data points like a standard thing? Or did they try other sizes?
Great question. They actually tested it with a larger window size of 90, doubling the data points.
Hmm.
And guess what? Our AI still held its own.
Really? So even with more data, it didn't get confused or anything?
Nope. Its RMSE went up a bit to 72.1 seats, but still way lower than the others.
Okay, so it can handle the pressure, but this was all on a vertical form fill seal machine. Could this work on other types of machines too?
That's the million-dollar question. And the researchers seem to think so. They believe that analyzing speed patterns, like this AI does, could be applied to lots of different equipment.
So it's like a universal language for machines. Wow, okay. So if AI can figure out a machine's health from its speed, what else could it potentially analyze? What other machine languages are out there?
Now you're thinking big picture. The possibilities are pretty mind-blowing. We could be using AI to analyze data from all sorts of sensors in our homes, our cars, maybe even our own bodies.
Whoa, like a personal AI doctor keeping tabs on everything.
Exactly. But before we jump too far ahead, let's stick with this research for now. You mentioned the AI is great at analyzing speed, but what's it actually picking up on? Is it like wear and tear or inefficiencies that could lead to a breakdown? It seems to be capturing those subtle changes in how a machine operates, things that are too small for us to notice, but they could signal trouble down the line.
So it's like the AI is listening to the machine's heartbeat, catching those tiny murmurs that might mean something's wrong.
That's a great way to put it.
Mm-hmm.
But like any new tech, there are always limitations. Did the researchers find any areas where this AI could be improved?
Oh, absolutely. They were very upfront about that. They even suggested a few areas for future research.
Oh, perfect. Let's dive into those. What kind of improvements do they have in mind?
One thing they mentioned was adding attention mechanisms. This would let the AI focus on specific events in the speed data that are really important for predicting failures.
So it's like giving the AI a magnifying glass, helping it zoom in on the key details. What else? They also talked about transfer learning, basically adapting the model so it can be used in other industries, even if they don't have as much data to work with.
Yeah, that makes sense. Not every industry is swimming in data like a big factory, so making this AI more adaptable would be a huge plus.
Exactly. And lastly, they mentioned making the AI faster so it could do real-time monitoring, maybe even on smaller devices.
Okay, now that's getting really futuristic. Imagine a little AI buddy keeping tabs on your car engine or your washing machine in real time. But before we get carried away, let's go back to the research itself. They used window sizes of 45 and 90, but how much data overall did they actually have? And what time period did it cover?
Good questions. They had a data set of 18,000 data points gathered over an entire year. That included both normal operation and actual failures, which is really important for training the AI to tell the difference.
So, like giving it a textbook of machine behavior with all the good and bad examples. But with that much data, did they run into any problems training the AI?
Well, they mentioned that time series data can be pretty tricky. Speed patterns can be really complex with lots of ups and downs, so it's not just about looking for one big spike or dip. The AI needs to be able to analyze all those patterns and find the subtle signs of trouble.
So it's like teaching the AI to read a really intricate language, the language of speed. Not easy. You mentioned earlier that they wanted to add attention mechanisms to help the AI focus. Would that need even more data or different kinds of sensors?
Good point. Adding those mechanisms might not need more data, but it would definitely make the AI more complex. Those mechanisms would have to learn which parts of the speed data are the most important for predicting failures. They might be able to do that with the current data, but it would take some pretty clever programming.
So it's about giving the AI better tools, not just more data. Makes sense. But speaking of data, how did they make sure their data set was, clean? Did they have to go in and manually fix any errors or weird data points?
Oh yeah, data cleaning is super important in AI. They pre-processed all the data to get rid of any noise or inconsistencies. They had to remove outliers, fill in any gaps, and make sure everything was on the same scale.
So, like prepping ingredients before you bake a cake. Got to make sure everything's fresh and measured correctly. But with all these technical details, what was the big takeaway? What was the so what of all this?
Well, the main point is that we might be on the verge of a real breakthrough in predictive maintenance. By using AI and focusing on something as simple as speed, we can learn a ton about how machines are doing. And this could have a huge impact, not just in factories, but everywhere.
Okay, so it's not just about making factories more efficient, it's about making machines more reliable, more eco-friendly, and just better integrated into our lives.
Exactly.
But before we get too philosophical, let's get back to the research itself. We talked a lot about the AI, but what kind of computer did they even use to train it? Was it some massive supercomputer or something more, normal?
Interestingly, they didn't need a supercomputer. They did it all on a regular computer with a good graphics card, a GPU, so this tech might be more accessible than you'd think.
That's really cool. You don't need to be NASA to get into this AI stuff. Did they release the code for their model, by the way? Could other researchers use it?
They didn't include it in the paper, but they said they're planning to make it public soon. So that's great news for the research community.
That's awesome. It's great that they're sharing their work. But, all this talk about AI doing stuff, it makes you wonder, will it eventually replace human jobs? Like in factories, are people going to be out of work because of this?
That's a valid concern. But I think it's more about AI creating new opportunities than replacing us entirely. Just like cars didn't get rid of the need for people in transportation.
So it's about AI helping us work smarter, not taking over completely.
Exactly. And the researchers had some advice for companies who might be hesitant about AI, maybe because of the cost or complexity. They said to start small, focus on one problem machine, and experiment. Build confidence before going all in.
So dip your toes in the water first. Don't just dive head first. Makes sense. But even if a company wants to try it out, what are some of the biggest hurdles they might face?
Often it's the human side of things. People can be resistant to change, especially when it comes to technology, especially if they're worried about their jobs. So communication is key, making sure everyone understands the benefits and feels comfortable with the new tech.
Right, so it's not just about the tech itself, it's about the people using it. But did they mention any examples of companies who are already using AI for predictive maintenance successfully?
While they didn't name specific companies, they did talk about case studies from a bunch of industries, manufacturing, transportation, even energy. And all those case studies showed real benefits, less downtime, lower costs, better safety.
So it's not just a theory, it's actually working out there in the real world. But with all this talk about AI in factories and stuff, do you think it could ever be used in our everyday lives? Like, could we have AI watching over our cars or appliances?
That's a great question. Researchers are definitely looking into that. Imagine an AI assistant that tells you your car needs a tune-up before anything goes wrong, or a smart home system that finds ways to save energy.
Okay, now that's a future I can get behind. But let's get back to the research one last time. We talked about the tech, the benefits, but what about data privacy? With AI collecting all this data, are there any concerns about how it's being used?
That's a really important point. And while this specific paper didn't go into detail about privacy, they did mention the need for responsible data management and protecting sensitive information.
Right, so AI needs to be used ethically and not just for profit or whatever. But did the researchers hint at what they might do next? What's the future of this research?
They mentioned a few exciting directions. They want to add those attention mechanisms we talked about to help the AI focus on the most important data. They also want to try transfer learning to adapt the AI for other industries.
Right, making it more versatile.
Exactly. And they emphasize that we need to keep researching the ethical side of AI, especially as it gets more powerful and widespread. We need to make sure it benefits everyone, not just a few.
Well, that's a great point to end on. We've learned about this amazing AI that can predict machine failures just from their speed, and we've talked about the potential impact it could have on industries, the environment, and even our everyday lives.
It's a really exciting field.
Yeah.
It really is amazing. And as we dig deeper into what this all means, we have to remember that the benefits of this AI go way beyond just preventing those breakdowns, like we talked about.
Right, it's bigger than just keeping the machines running smoothly.
Totally. We're talking about like a ripple effect impacting everything, like from productivity and saving money to worker safety, even sustainability.
Yeah, and speaking of keeping things running smoothly, let's talk about worker safety for a second.
Mhm.
Imagine a factory where, like, potential hazards are identified before they can even become a risk to the people working there.
Right, like a much safer work environment.
Exactly. That's the peace of mind this technology could bring. And speaking of well-oiled machines, let's not forget about sustainability. How does this AI fit into making industries greener?
Well, if you can predict and prevent those failures, you can make equipment last a lot longer, which means less waste, less need for replacements. And if you can optimize how machines perform, that means you're using less energy, fewer resources overall.
So it's not just about smarter factories, it's about greener ones too.
Yeah.
It's pretty cool. Now, this research was all about a specific machine in like a manufacturing setting, but I can't help but think about other industries. Where could this AI be applied?
That's what's so exciting about this. The principles behind this tech, they're super versatile. Like think about transportation for a second. Analyzing speed patterns in trains or airplanes could be huge for safety, preventing those kinds of accidents.
That makes sense. So this AI could be a game changer for any industry that uses complex machinery, not just keeping things running smoothly, but also making sure everything is safe for passengers and cargo. What other sectors come to mind?
Well, even in healthcare, think about it. Analyzing the speed of medical equipment or monitoring vital signs that could give doctors crucial early warning signs of a problem.
No. Wow. So we're talking about factories, hospitals, transportation, energy. This could really transform how we operate and maintain all these critical systems.
Okay, so we've talked about how this AI stacks up against other models, but I'm still curious about why speed is such a good predictor of failures. Is it like catching wear and tear early on, or is it about finding those inefficiencies that put stress on the machine?
The research seems to suggest that looking at speed gives the AI a more holistic picture of the machine's health. It's not just about one part wearing out. It's about seeing how all the parts are working together and how those relationships change over time. Speed is like a language that reflects the overall well-being of the machine. So it's like a doctor listening to your heartbeat. They're not just checking for a steady rhythm. They're listening for those subtle murmurs or irregularities that could point to a bigger problem. And the AI, in this case, it's like the doctor's speed is the machine's heartbeat.
Yeah, I like that analogy a lot. And what's so cool is that the AI isn't just passively listening, it's actively learning,
Mm.
with each new piece of data. It's getting better at understanding what's normal and what's not. So it becomes more accurate and insightful over time.
Like a student getting better with practice. Okay, so the AI is learning and getting smarter, but are there any limits to what it can tell us? Are there some types of failures it might miss if it's only looking at speed?
Yeah, that's a really good question. And the researchers do admit that no model can predict everything perfectly,
Yeah.
especially when you're just relying on one type of data. They point out that like sudden catastrophic failures where something just breaks unexpectedly,
Hmm.
those might not always show up in speed changes.
Right, so it's not a perfect crystal ball. Some things are just unpredictable. But even with those limits, the benefits are pretty clear. It's like having extra protection, a safety net to catch most of those problems before they get really bad.
Exactly. And, as this tech keeps developing, we can expect these AI systems to become even more sophisticated, maybe combining data from different sources and getting even better at predicting those failures.
Okay, so imagine a future where AI isn't just predicting failures, it's actively preventing them by, adjusting how the machine works in real time, like a true partnership between humans and machines working together.
Now you're talking about the next level of predictive maintenance. It's a future where AI isn't just a tool, but a partner, helping us create a more efficient, more sustainable, and ultimately a more harmonious relationship with the machines that power our world.
Yeah.
Okay.
Now, that's a future I can get behind, but let's bring it back to the present for a second.
Yeah.
If a company wants to try out AI-powered predictive maintenance, where should they even begin?
I'd say take a look at what data you're already collecting. A lot of companies are sitting on mountains of data, and they don't even realize it. Look for anything that tells you about how a machine is operating, speed, temperature, pressure, vibration,
Oh.
even audio recordings.
So, like digging through your closets, you never know what you might find once they have the data. What's next?
Well, then you need to find the right tools and expertise.
Mm-hmm.
There are tons of AI platforms and software out there, but finding the right one depends on what the company needs and what resources they might need to train their employees or even work with experts in AI and data.
So it's not a one-size-fits-all solution. It takes planning and a willingness to try new tech and new ways of doing things. But speaking of new ways of doing things, do you think this AI stuff will change how people work in factories and other industries? Like, are we all going to be out of a job?
I get why people ask that question. It's a natural concern. But honestly, I see this as an opportunity, not a threat. Just like the invention of cars didn't get rid of transportation jobs.
Mhm.
AI-powered predictive maintenance will just create different roles,
Yeah.
different opportunities for skilled people.
So it's about making us work smarter, not harder. I like that. And speaking of working smarter, did the researchers give any advice for companies that might be worried about the cost of AI or how complicated it is?
They did. They said it's important to start small. Instead of trying to change everything at once, just pick one problem or one piece of equipment and experiment. Gather data, see if it works before doing anything big.
So dip your toes in the water first. Don't jump in the deep end. That's smart. But even if a company wants to try it, what are some of the biggest challenges they might run into? Is it like people not liking change or not having the right expertise or something else?
Yeah, often it's the human element. People don't always like change, especially when it comes to technology, especially if they think it might replace their job. So communication is super important. Make sure everyone understands how this can benefit them and make them feel comfortable with the new tech.
It's about bringing people along on the journey, not just forcing change on them. And did they mention any real world examples of companies using AI for predictive maintenance successfully?
They didn't name any specific companies, but they did talk about case studies from a bunch of different industries, manufacturing, transportation, energy, and all those case studies showed real benefits. Things like less downtime,
Hmm.
fewer costs, and safer workplaces.
So it's not just a theory, it's working for people right now. Okay, we've talked a lot about AI and factories and all that, but do you think this could ever be used for everyday stuff? Like, could we have AI watching over our cars or our appliances at home?
That's a really interesting question, and it's something that researchers are already working on. Imagine an AI assistant in your car that tells you when you need a tune-up before anything breaks,
Mm.
or a smart home system that helps you save energy by keeping your appliances running efficiently.
Okay, now we're talking. This AI stuff could really change how we live. But let's come back to the research for a minute. We talked about all the cool tech and the benefits, but what about privacy with AI collecting all this data? Do we need to be worried about how that data is used?
Privacy is a big deal, and it's something we need to think about carefully. While this paper didn't focus on the specifics of data privacy, the researchers did say that we need to manage data responsibly and protect sensitive information.
AI needs to be used ethically, not just for profit or whatever. But did they mention anything about where this research is going next? What are they working on for the future?
They mentioned a few things that they're excited about. First, they want to add those attention mechanisms we talked about so the AI can focus on the most important data points And then they want to try transfer learning, so the model can be used in other industries even if they don't have as much data.
So making it more flexible and adaptable.
Exactly.
Yeah.
And lastly, they said we need to keep researching the ethical implications of this tech.
Mhm.
As AI gets more advanced and we start using it everywhere, we need to make sure it benefits everyone, not just a select few.
That's a really important point. We need to make sure AI is a force for good in the world. Okay, so we've talked a lot about the cool tech behind this AI and all the potential it has, but now I want to shift gears a bit and talk about what it all means for the average person listening to this. What are the key takeaways and what questions should this research spark for them?
I'm ready to dive into that final discussion.
And we're back for the final stretch of our AI-powered predictive maintenance deep dive. I don't know about you, but I'm still processing all this incredible information about machines talking to us through their speed.
It is pretty mind-blowing when you think about it, right?
Sure.
Who knew speed could be so insightful? And like we've been saying, it's not just about avoiding those breakdowns. It's about making machines work better, safer, and greener.
Absolutely. But before we get lost in all the amazing possibilities, let's make sure our listeners are equipped to take this knowledge and, do something with it. So, final takeaways time. If someone's listening and thinking, hey, this AI stuff sounds pretty cool, what's the first thing they should do?
Honestly, just start paying attention. Look around you at work, at home. Think about all the machines we rely on every day. Start noticing the data they generate and ask yourself, what's this data telling me? Could it be hinting at a problem before I even see it?
So, become a machine whisperer, basically. Learn their language, which apparently is speed.
Oh.
But once you're tuned in, what's next? How do you turn that awareness into action?
Well, there are tons of resources out there. Online courses, articles, even open source AI tools. Don't be afraid to experiment, tinker around. Learning by doing is always the best way.
Right, so embrace your inner tinkerer. You don't need a PhD to start exploring this stuff. And this research focused on a very specific machine, but what other kinds of data could be used for this? Could we use sound, images, even text to get a more complete picture of how a machine's doing?
Definitely. That's what's so exciting about this field. It's constantly evolving. Researchers are already looking at combining different types of data, sound, images, text, you name it, to get a much richer understanding of machine behavior.
So it's like giving AI superpowers, allowing it to see, hear, and feel those machines in totally new ways. But with all this data floating around, what about the ethical side of things? What do we need to be careful about as we develop and use these AI systems?
That's a huge question, and rightfully so. We have to make sure AI is used ethically and responsibly. We need to address those concerns about data privacy, bias, and how this technology might affect jobs.
It's about making sure AI benefits everyone, not just a select few. And speaking of benefits, if we zoom out to the big picture, what could AI-powered predictive maintenance mean for society as a whole?
Well, imagine a world where all our critical systems, power grids, transportation, even medical devices are constantly monitored and maintained by AI. We could achieve levels of efficiency, safety, and reliability that we've never seen before.
It's like creating a self-healing world where problems are solved before they even happen. And what about the environmental impact? Could this help us create a more sustainable future?
For sure. By making machines work better and last longer, we're automatically reducing waste, using less energy, and shrinking our footprint on the planet.
So this AI isn't just making machines smarter, it's helping us build a smarter, healthier world. And as we wrap up our deep dive, I want to leave our listeners with one final thought to chew on. We've talked a lot about predicting the future of machines, but what about our own future? Could this technology be used in healthcare, education, even personal development to help us make better decisions and live more fulfilling lives?
Now that's a deep dive I'd love to be a part of.
And on that note, we'll let you explore those possibilities. Thanks for joining us on this journey into the fascinating world of AI-powered predictive maintenance. Until next time, keep learning, keep questioning, and keep imagining what this technology could do for us all.